Hi everyone, welcome to our webinar today. The topic for this webinar is Solar+Storage Industry Perspectives, and we have guest speakers with us from JLM Energy. This webinar is a presentation of the Resilient Power Project. The Resilient Power Project is a project of Clean Energy Group, and our host for this webinar is Seth Mullendore. Seth is a project director here at Clean Energy Group, and he will be introducing our speakers and talking more about our subject today. Before we get started, there are a few housekeeping notes on your screen. And with that, I would like to pass it over to our host for this webinar, Seth Mullendore. Seth?
Thank you, Sam, and thanks everybody for joining us today. I'm just going to give you a little bit of background about our organization first before we start the presentation today. The Clean Energy Group is a national nonprofit organization. It's been around for about 20 years. We also have a sister organization that is Clean Energy States Alliance. The Clean Energy States Alliance is a membership organization of state energy fund managers. Clean Energy Group, one of our primary projects is the Resilient Power Project, which is a joint venture with Meridian Institute. And these are a number of the foundations that support that project listed here. I'd like to give you a little bit of background about what the Resilient Power Project is. This is presenting the webinar today. So if we go to the next slide. The Resilient Power Project, it really came in the wake of Hurricane Sandy as an alternative way for communities to have backup power and have more resiliency in the face of a natural disaster. Since then, the project has really expanded to include not only resiliency by providing emergency backup power when there is a need for it, but also providing economic resiliency, so reducing the energy burden for communities. The way that we primarily look at providing this resilient power is through a combination of solar, usually rooftop solar, combined with energy storage, typically battery storage. We do a lot in this area. We put out a lot of reports. Some of those are listed along the bottom. And we also work with a lot of policymakers, both at the federal and state level, and city officials as well, to help get a plan together, a strategy for resilient power. We also work with individual projects, so that can be, well, our focus is on low-income communities in particular. So low-income communities, we have two primary focus areas, which is affordable housing and critical public facilities, which could be anything from community shelters to healthcare facilities to first responders. In addition to helping these sorts of organizations and community buildings figure out if energy storage and solar make sense for their facilities, we can also provide some small grants that can help them actually figure out an analysis of the technical and financial feasibility. We also work with states and things to advocate for programs and policies that can make these systems make more sense, particularly for low-income communities. And we put on a lot of informational webinars, newsletters, and reports. If anybody's interested in learning more about the Resilient Power Project, we have a lot of information on our website, which is a screenshot here. And I urge anyone to check out the website. You can join our mailing list and follow us on social media, Twitter, and Facebook. So with that, I'd like to get the presentation started off today. We have a couple of great speakers with us from JLM Energy. First up, presenting today is going to be Ellen Howe. Ellen is the JLM's Vice President of Marketing and Corporate Development. She leads JLM's branding, strategic communications, and corporate development initiatives. During her 3 decades of experience, Energy has served as a senior spokesperson for the U.S. Department of Homeland Security, Vice President of Marketing and Business Development at VidSys, and with L3 Security and Detection Systems. She has opened new markets and honed her communication skills on complex subjects, including technology, energy, security, global leadership, natural resources, and risk management. These experiences make her acutely aware of the need for resiliency in the global energy supply and a diverse energy portfolio. And then with us for the question and answer section of the presentation today is Roman Couvrette. He is JLM's Director of Project Marketing. Roman serves as a liaison between JLM's engineering, sales, and marketing teams And his hybrid knowledge of engineering and sales helps him provide scope and direction to new project development. Roman is an experienced technical trainer and is an expert on the benefits and use cases for all of JLM's products. With that, I'm going to turn it over to Ellen Howe to begin the presentation.
Okay, great. All right, so our company was founded by two entrepreneurs with successful track records in software startups, both over in the Silicon Valley. And our CEO, Fareed Dabachi, has a compelling story. He came to the United States in 1979 from Iran during the revolution, and JLM is his fourth startup, technology startup. So you can go ahead and advance it from there. And we'll go to slide 3. At JLM, we pride ourselves on the fact that we're innovators, not integrators. We offer a comprehensive solution and we develop our products in-house. We'll go to the next slide. Americans use an astounding $400 billion worth of electricity every year, and this is only going to increase as more people drive electric cars. The time now is right for storage because of the decrease in the cost of solar and an increase in storage technology capabilities. At JLM, we're focused on getting the levelized cost of electricity in the 11 to 13 cent range, and we believe that's very achievable. Next slide. You can see here that renewables on the grid have increased dramatically in recent years. We see utilities as force multipliers for our business, especially in states with aggressive net zero goals, because utilities are going to be part of the solution of getting us to cleaner energy generation. Next slide. In fact, utilities are the newest market that we serve. We offer commercial and residential solutions and have done so since our company was started in 2011. And here are a few pictures of some large projects that we've done, and we'll talk more about some of those specifics later in the presentation. With our new product Phaser, we'll move into utility scale applications as well as provide demand response solutions. Next slide. Since you're on this webinar, it's likely that you know about the challenge of the duck curve. Solar feeds into the grid during the afternoon hours, but the energy is needed during the spikes late in the day when solar is no longer producing and people come home from school and work. Go to the next slide. Our solutions help our customers seamlessly manage the solar energy that they produce so that they can use it when they need it most. The challenge with Solar+Storage is that we really need costs to fall significantly to allow for widespread adoption. And we should be on that next slide, and we can jump to the following one now. Thanks to better manufacturing processes, the cost of solar panels and batteries are continuing to drop. The challenge, however, is that the cost of hardware represents around half the total cost of any system. Next slide. JLM brings innovation in how systems are designed, built, and used, and this enables us to lower costs in every category, finally achieving the price point needed for widespread adoption. We do this through innovations like our new MicroStorage product Phaser and increased efficiency using our patent-pending symmetric DC regulation. We're going to talk more about that in a few minutes, but right now what you see on your screen is Phaser, our MicroStorage technology. It's a small battery pack that pairs with a single solar panel, and it forms a highly scalable solar plus energy storage system. And we're pleased to say that Phaser has completed its UL testing, and it's already self-supply certified in Hawaii. Next slide. And this one has 2 clicks. So you can't really underestimate the paradigm shift Phaser represents. It's as transformational as the shift back in the day from mainframes to PCs. And the next slide also has 2 clicks. Bulk storage can provide a lot of energy, but it also takes up a lot of space. With MicroStorage, you'll find that big power can come in small packages. Next. We're already selling Phaser, and our first units are going to ship out in May. And we'll go to the next slide. And this one really shows you right there that Phaser installs on the solar panel racking. It sits right next to the microinverter. The solar panel goes over top of it, and it shares, it uses standard connectors to the panel and the inverter. And now I want to tell you just a little bit while we're on this slide about symmetric DC regulation technology. It's a patent pending technology that we've developed, and it has less parts, so that makes for higher efficiency. We don't use a boost controller or a charge controller, so the energy goes directly from the solar panel either into the battery, but if it's going to 2 other places, back to the grid or into the building, it doesn't have to cycle through the battery. And in an even more innovative development, Phaser can take that solar energy from a single solar panel and send it to 2 places concurrently. So you can be charging the battery and also sending power into the home or the building for real-time use. Now we'll go to the next slide. So the result is virtually 0 installation, design, and maintenance costs, improved reliability and safety, and the lowest total cost of ownership in the market today. I'd like to point out that we use lithium iron phosphate battery chemistry, and those batteries are more structurally and thermally stable than the common lithium ion batteries. And because we reduce cycles with our symmetric DC regulation technology, we offer the only 20-year warranty in the business. Phaser has 2.5 hours of capacity, and each solar panel can be paired with up to 2 Phasers to achieve a maximum of 5 hours of storage. Next slide. Are you there, Sam?
It should be. I think there's a little bit of delay.
Okay. So Phaser is a bite-sized opportunity. You can put it where you need it. You can add more if you need to. It's an asset that can be redeployed to other properties as needed, and it can be retrofitted to existing solar. You can put it on the roof or on a parking structure, and it doesn't take up valuable wall space in a housing unit or garage. We like to say Phaser is easy. Next slide. So just to go over some of the key differentiators of Phaser, again, with symmetric DC regulation technology, it's the first energy storage system that makes it possible for a solar panel to charge a battery and use the solar energy in the building at the same time. And because it's designed to charge only from solar, it's fully qualified for the federal investment tax credit. Phaser is fully insulated and protected from hot and cold outside temperatures, and it operates at a low voltage that is safer for installers and consumers than high voltage systems. Next, we'll go to our transition slide and just mention that we're going to talk about our ecosystem approach for home and enterprise. And for the purposes of this discussion, I'm going to talk about homes initially, but keep in mind that these same tools can be applied and used effectively in enterprise settings as well. So this little slide has a bunch of clicks. To provide the most well-rounded solution, you need to manage demand in every way possible. So we've developed a tightly integrated ecosystem that unites a number of elements, including smart thermostats, load controllers, and monitoring systems. We do this for both residential and commercial applications. The challenge with a smart energy ecosystem is knowing the right combination of technology to use and making sure that they work together seamlessly. So we'll hop on over to the next slide. At JLM, all of our products are deployed and monitored and managed on a unified cloud-based software platform called Measures. By interacting with energy use through our user-friendly app, customers can learn to make small lifestyle changes, like what time of day is optimal to run the dishwasher or the dryer, and they can, create behavioral energy efficiency that helps them conserve energy and also save money. And we actually quote all of our jobs through measures. There's a part of it that's a way to design and build systems, and then deploy. When you deploy the system, you have the historical knowledge of the individual customers' habits and their tariff structures. And measures is always going to be working behind the scenes to optimize the energy and make the best possible deal for that owner of the system. So now we're going to go to the next slide, and we're going to show you a screenshot of measures. And I'd just like to add that if you would like to have a demo of the software, and this one has a lot of clicks on it, Sam, to bring in all the elements, we would be happy to provide you a live demo of the software at another time. You just need to reach out to us afterwards. So what you're seeing here is a key over on the left. It shows the building loads, where the grid is importing energy, where the grid is exporting energy, where the batteries are discharging. It's really the visibility is the greatest asset that measures brings. So you can see exactly how much power the building is using and have visibility into all the components. And it's just a complete set of tools. So you can see where the energy is being imported from the grid. The yellow is the sun. The purple shows that they're making more solar than they need right now. So some of it's going back into the grid, and the batteries are discharging on the dark blue and charging on the light blue. Gray is where they're exporting. And I meant to also tell you that it's literally second by second data. So you can interact with it as much or as little as you like. And you can also see that we include weather data up there, so you can kind of plan ahead and know whether your solar is going to be producing in the days ahead. And we'll go on to the next slide, and we'll show you a component of hardware screenshot. This is Phaser, where you literally get visibility into each and every battery cell, and you can look at the health of the system and the state of charge of the system. Now we're going to move into several examples of community projects that we've done. And this first one is Bear River, a tribal community in Northern California. The Bear River tribe was very passionate about the renewables, and they liked the idea of using solar and wind. But to truly create a cost-efficient model that reduced demand charges, they incorporated energy storage into their system. Independence is also very important to the tribe culturally, so they wanted microgrid capability, and now they can use their energy storage in a grid-tied or a grid-independent mode. And you can see that project there actually did incorporate our small micro wind turbines called Zephyr. And we'll jump to the next slide. This slide highlights North Putnam School District in Bainbridge, Indiana. These folks wanted to build a solar system that was so big that it exceeded the capacity that Duke Energy could transmit back onto the grid. So by adding storage, the batteries act like a sponge and absorb the excess energy generated. In addition to having their energy costs optimized for the next 20 years, students can interact with the energy use via the software platform, and the school now serves as an emergency response shelter because of its resilience. Next slide. I'd like to share with you a little information about our target markets in the commercial and residential sectors. Commercially, we've fielded over 20 projects nationwide, and those include golf courses, tribes and casinos, printing and packaging facilities, plastics and metal processing, food processing, and churches and schools. In the residential market, we went direct in 4 states last year, and you can see these are the states that either have issues with net metering or have implemented time of use charges: Arizona, Hawaii, and Nevada, and then starting in Southern California early this year. So I'd just like to conclude by saying that we're committed to continued technology innovation that drives the distributed energy forward in the marketplace. And I'd like to turn it over to my colleague Roman to take on the Q&A portion of the program. Thank you.
Great, thank you, Ellen. This is Seth again here with Clean Energy Group. I'm going to moderate the questions. We've had a few come in. I encourage anyone that does have additional questions to please submit those now, and we'll get to them, assuming that we have time, which we have a good amount of time right now. So this would be great, and I also want to let people know this is kind of our kicking off our industry perspectives series that we're going to be talking to other companies within the solar and storage space. Letting them know about what they're doing in the sector, and letting you know about new innovations that are coming to the market. So with that, Roman, there's been a couple of questions. I think people are a little bit confused about how the equipment, the phaser equipment actually gets installed on the roof. Does it take up its own individual space on the roof, or is it actually mounted behind solar panels so it doesn't take up any additional square footage?
Yeah, so the answer is that it's mounted behind the solar panels using the same railing system and does not take additional square footage. We had a couple good images of this. I'll try and go backwards in the slides here to illustrate that, but it basically has the exact same type of rack mounting hardware as a microinverter would. And by the way, if you were to use a different style of racking system, such as a ground mount system, it would use the same methodology of mounting on the rail behind the solar panel.
Great, that's good to know. As I said, it doesn't take up any additional footprint of the area. I had a couple of questions about, because it is on the roof, how does it perform in extreme weather conditions, extreme heat conditions? Particularly, people were interested about in the Southwest. How does that lead to the performance of the battery? Does that shorten the life cycle estimates of the battery, or the complete life expectancy of the battery?
Yeah, good question. So I'll make it noted that this is actually our second generation of NEMA 3R outdoor rated battery systems, and that phaser did go through recently and pass UL certification, which did test it for extreme temperatures of both hot and cold. One of our primary markets that we deploy these units in is Arizona, so I can tell you that we're no strangers to hot temperatures. As far as life expectancy is concerned, it's definitely a factor you have to consider, hot and cold, but again, this is certified at its warranted amount of 5,000 or so cycles at 80% depth of discharge in any region. So hopefully that answers your question there, but it can survive in any of those markets.
Great. So since we're talking about phaser, I've got a few more questions about that. What is the actual chemical composition of the battery?
The batteries in phaser are lithium iron phosphate, which is a very specific chemistry. JLM, we have been deploying systems of different chemistries for years. Originally, we've used AGM, absorbed glass mat. Lithium iron phosphate is by far our most common deployment for several reasons. You get plenty of cycles out of them. The energy density is very good. And also from an electrical perspective, there's certain characteristics about that chemistry. Like, for example, their ability to perform very well even when they're closer to empty. And the safety features, of course. It's a very thermally stable chemistry. Those are the main reasons we've used it for phaser. But I do want to point out that we are somewhat battery chemistry agnostic. If you look at some of our other containerized solutions, for example, some of those that that Ellen showed in the pictures, where you'd have a large shipping container or maybe a pallet-sized outdoor unit, we can use other chemistries like lithium ion or AGM as well. But Phaser in particular is lithium iron phosphate.
So what is the what is the expected calendar life of one of those units and the life cycle expectation for the life of a Phaser battery?
Another good question. So for any battery, the life is measured in the amount of cycles you would get, and then the amount of cycles you get are dependent on your depth of discharge. Meaning, if you drain a battery closer to empty every time you use it, aka a deeper depth of discharge, you're going to get fewer cycles out of it. That's just a little background. Phaser and our lithium iron phosphate batteries in general are expected to get 5,000 cycles at 80% depth of discharge. If you wanted to get more, you could set up a system that never goes below 50%, meaning you would just add more batteries and utilize them slightly less. And there's a lot of things you want to consider when you're picking the right chemistry for the job. Like, for example, what are you trying to do with those batteries? If you're doing demand shaving, chances are you're not going to be cycling the batteries completely every single day, in which case you would be okay to use them up to 80% depth of discharge, getting less cycles. Whereas if you're using them for a different application like solar self-supply, where the goal was to absorb all excess solar, never net meter, and therefore use the batteries on a daily basis, you would want to be a lot more conscious and probably use 50% depth of discharge. But at the end of the day, I think what people are concerned about when they ask questions about how many cycles you get are how long is this thing going to last me? And I think the 20-year warranty is going to be your peace of mind there. Phaser does have a 20-year warranty that does include battery cell replacement.
Wow, yeah, I think that's what most people are trying to get at with this, and that's an impressive warranty. I know that industry standard, from what I've seen so far, tends to be about half that, the 10-year warranty. So that's definitely additional peace of mind for folks. So I'm going to move a little away from Phaser, but we'll be back to it. We're getting a lot of questions coming in now, so I'm just going to run down the list of some of the earlier things so we don't miss those. There was a question when we were talking about the measure software, about how you maintain your utility tariff database. I know there's a lot of utility tariffs out there and they change often. So I think this is actually a pretty good question on how you're able to maintain that and keep it up to date.
That's a good question, and I'll tell you that there is plenty of manual work still involved at this stage. We do start off using a very large rate plan database that's hosted by NREL in Colorado. And NREL, of course, is, if you know them, then they were set up originally by the Department of Energy, but that has about 30,000 rate plans, and we do have to keep that honest, I guess you could say, by checking on rate plans, which utilities are required to list by regulation every few months. So again, a lot of manual work, but I would say our 30,000 rate plan database is one of the more extensive and up-to-date available.
That's great. I'm very familiar with the NREL database and the work they do on that. A question about how you scale for commercial energy storage projects. I assume this is again related to Phaser. When you're talking about just a handful of modules, installing them individually, it doesn't seem like a heavy lift. But what about when you get more to the commercial scale, when you get into 100 kilowatt projects for solar, and you're talking about a really big number of panels that you're dealing with?
Yeah, good question. So I want to point out that there's two different styles, or a few different styles of commercial storage. Phaser is certainly designed and is a great candidate for those large-scale deployments. But if I was to, I'm going to go back a picture or a few slides to try and find an image here that shows some of our other styles of systems. So depending on the application, we may go with a variety of different form factors here. We can do an indoor or portable skid unit that is basically a very condensed system. The advantage here is the fastest turnkey integration, basically shows up very plug and play. And we can also go into 20 or 40 foot shipping containers. That would offer the highest energy density. And then Phaser, I actually think, is the better choice. Even though it is a small unit, like Ellen said, it can deliver a lot of power because it's very quick to install, and you can have one per solar panel that has about 0.75 kilowatt hours of storage per unit, aka with a 250 watt panel, about a 2.5 hour battery. If you add that up, it's actually a very significant system size without taking any footprint at all. And I think what's interesting to note with Phaser too is that it's actually the lowest total cost of ownership option of all three of those. And the reason why is that the installation of it is virtually zero cost. It doesn't require any special talent or certified electricians or engineering necessarily to be able to bolt the units on and to plug the MC4 connectors in. And there's no design work that needs to be done really because it's a one-to-one ratio. And so by reducing those specific costs, I think even though we have those three methods, each of which could be scaled up into any size you really need, I think Phaser is the best option for scalability just because you're saving on those soft costs of installation.
So, speaking of costs, people always ask, and you can answer this if you want or not. What is the per unit cost of a Phaser? Or if you can give the unit cost in kilowatts, kilowatt hours, if you're willing to share that information.
Sure. Now, the goal and what we think is required for widespread adoption is for system cost to be less than $500 a kilowatt hour, and Phaser is pretty much right on the mark there.
That's the installed cost?
No, for the unit. But again, there's no installation costs really. So at the end, you really are ending up at, in the $500 range for installed storage with Phaser.
That's great.
It's a little out.
Yeah. So what about the weight impact of the Phaser? As far as putting these on the roof, that can be a pretty big factor when people are considering what hardware to use.
Yeah, good question. So clearly that was one of the major considerations we had to look at. We've had plenty of professional engineering reviews and everything, and it was a part of the UL certification was to examine that load. I don't have some of the exact numbers. I believe it's about 1 pound per square foot added onto the roof, which again, after we've run through the engineering reviews, was not a problem and allows them to be permitted.
Great. So how about their compatibility with inverters? In this, you showed them with the N-phase inverters. Do they work with other brands as well?
Yeah, it's designed to work with any grid-tied standard microinverter. So, for example, APS microinverters, it would work with as well. Great.
Some additional questions just about the temperature concern. So one is, again, on the heating side. Does Phaser have an acting cooling mechanism within it, or is it just that technology is so resistant to high temperatures that it doesn't need it?
In general, it is resistant, but just so you know, there are safety, mechanisms built in. We have battery management systems, BMSs, that are monitoring cell temperature, among other things, on a cell-by-cell basis, meaning every single small battery within Phaser. And if anything, if it was ever to be outside of the operating temperature range, which I don't have off the top of my head, but if you download our spec sheet off our website, you will find it there. Then the system can shut off individual units while allowing the other ones to continue to operate. Kind of back to that point we were making, that there's no single point of failure, but temperature certainly is something that's regulated, and there's several layers of safety precautions built in, just in the fact of the casing itself is resilient to temperature, but also that if cells were to get hot, we would detect and shut them off.
Great. So how about on the other side of the spectrum? One of our attendees seems to be familiar with lithium iron phosphate, and was wondering, to their understanding, that they cannot be charged at below freezing, so below 0 degrees Celsius. Is that true? And if so, how do you address that?
You know, to be honest, I'm not a foremost expert on that particular topic. So I think I would encourage whoever that person is to probably get in touch with us and maybe pair with one of the engineers. You know, at this point, it sounds like we're starting to get into particulars about lithium iron phosphate chemistry versus kind of the MicroStorage methodology that we were discussing here. But again, I don't want to not have an answer for that. So please, I encourage you to inquire with us so I can pair you up with an engineer for that question.
Sounds good. Don't expect you to be able to answer all of these. That's for sure. And so a couple of questions about Phaser as a source of backup power. Are they able to provide backup power in a grid outage scenario?
Actually, Phaser is a grid-tied system, and the reason why is because it is using that grid-tied microinverter, which is programmed to shut off when the grid disappears. Now, we do have a solution for that. We often do set up microgrid systems here at JLM, and what we would do with Phaser is pair it with a grid-forming hybrid inverter. We have a couple different versions of that. One of them is a residential version known as Energizer 100. There are plenty of grid-forming hybrid inverters in the commercial space. Basically, in addition to your solar outfitted with phasers, you would have a separate external small battery with its own inverter to kind of act and play the role as the grid. It would do the grid forming. It would send out a signal to all those inverters to stay on and operate. And so you kind of see that as a small adder on a project if you want the microgrid capability.
Okay, so just to be clear, so you wouldn't need to add enough storage capacity to be able to cover the stored amount that you would need in a power outage situation. You would just need a fairly small size battery that would be able to send a signal, basically send electricity to the system to let it know that the grid is actually there, even though the grid isn't there. Is that kind of the idea?
That's right. And then once those that signal is sent and those systems are able to stay on, you have the energy capacity of the phasers that are now still functioning at your disposal. So it is a minimal sized battery with a very specific reduced role of grid forming.
Great. Oh, that's really interesting. So as far as any impact to building codes for these, you know, this is kind of a new area you're getting into here. Are there any structural or fire protection concerns that are specific to the phaser? And there's a question about if there's been an application approved by Factory Mutual or IRI, which I'm not that familiar with. Maybe they mean more to you.
Yeah, and I'm not actually familiar with those either. I think what might be helpful and probably not something we can do on this call since I'm not prepared with the info is to collect some of the information from our UL testing that, like I mentioned, did test the entire setup and its weight limitations, I guess, and the impact it would have on what it's mounted to, and see what those results were and kind of share that. But I do know that we've passed the designs over to structural engineers, professional engineers for stamps, and they have been approved for several different scenarios. But you know, unfortunately, don't recognize those two certifications you mentioned.
Sure. And, I encourage anyone that does have remaining questions to reach out to Roman or Ellen or myself with any additional questions, or just to pass along information. And we'll get extra information to you if possible. So I'm sure the folks at JLM will be happy to follow up with anybody. So question, is Phaser ready for market now? Is it ready to go?
Yeah, I would say so. I think what I would define as ready for market would really be having passed the UL testing, and which it did recently, and production is underway. So if people are interested, I think we've had several thousand pre-orders that are shipping out, I think in May, which is coming up sooner than you think. It is something that's available that we're providing training and having conversations about volume, et cetera, right now. So it is ready.
Right. So another question about the measure software. Well, there was one question, and I can't remember if this was addressed or not, is if it is able to do a peak shaving applications, and then just a general question about how the measures software might be different from other energy software systems that are out there.
Yeah, that's a great question. I think that would actually even maybe justify an entire different webinar. Measures is something that's very near and dear to me. I helped develop this software from the ground up. What I think is fundamentally different about it is that it really is an end-to-end software. And what I mean by that is it has a planning and design component. Before you install a system, we have a tool in there which you can input a customer's usage data, and you can model out different tariff structures, different system sizes, different control algorithms, whether you're trying to do demand shaving, solar self-supply, time of use shifting, any of the main performance algorithms out there, or combinations of them. You can model the system out, figure out all the different financial savings and system settings that you would need to achieve a certain return on investment. And then there's an entire other side of it that is fleet management. So when systems actually get installed, you can log into measures and you can see a map of all of the different deployments out there. You can tap into individual sites and you can view the system health and performance. You can remotely control them, and you can even do aggregated system control. So if you are a solar installer who's got 100 residential battery sites in the state of California of like kind, and you decide within a same utility, and you decide that you want them to act in unison with each other as kind of some sort of service or grid service you're providing to a utility, you can use measures for that fleet management aspect. And I think it's really special that we've connected those two worlds of planning and deployment, because you can ask any investment company about this, that it's nice when there is a consistency between what was projected and what was installed, because as soon as you design a system and measures, all of those settings get imported over into the actual system that's deployed, and our ability to create those savings and have the system do what it was designed to do are greatly enhanced because of that connection and consistency.
Great, thank you for that. So I was just looking at a question we have here, and that's really related to the work we do through Clean Energy Group through our Resilient Power Project, asking specifically how this could be applied to affordable housing and critical community facilities, specifically on rental housing, which I think brings up an interesting point that I know we've wrestled with a lot here, is kind of the split incentive between properties that where there's a lot of renters. So there are arrangements like virtual net metering in California, where you can apply a system on say multifamily housing to the common area, to the building itself, and then some to individual renters as well, usually as a percentage. With something like a phaser, where you have individual units where you know what's going on with each one, would it be possible to even go more granular than that, so that you can actually have specific solar and storage assets that kind of are applied to each meter within a building. This is just kind of throwing a thought out there to get your ideas on that, Roman, to see if that sort of thing would be possible with this, or more feasible than, say, a large system that just has, you know, a few inverters and a big battery.
Yeah, I think there are two things you would want to do in a situation like that. You would want to have some sort of storage system that can have different strategies going on at once. So, you know, in a single building that has multiple tenants, you're kind of attacking, you know, tens or maybe even 100 different unique needs at once. And if you don't have a system that's distributed like Phaser, where each battery can be operating on its own agenda, it's hard to fight that. You know, you kind of can only do it as a big aggregate versus kind of those individualized strategies. I think the better way to do it is actually on this ecosystem slide I'm showing. One thing that makes JLM unique too is we do a lot more than just install battery systems and solar. We have this whole collection of other products, including load controllers, which basically attach to individual appliances and allow you to turn them on and off, or have them automatically be turned on and off based on a customer set budget, or when demand signals are sent from the utility. We tie in smart thermostats, mainly through our partner Honeywell, and we also have our own thermostat line. And then also we have real-time power monitors, unlike lines here, which give you up to the second insight into your usage. If I was to try and help someone in an apartment that didn't have a rooftop of their own, they don't have space to put a battery, but they are interested in somehow reducing their energy bill and being part of, you know, energy efficiency and et cetera, I would probably explore all these other tools in my belt at first. And between this whole arsenal, you're usually able to find one or two or a combination of these smaller technologies that can fit for really any situation, even those where you don't have room for a battery.
Yeah, it's really interesting. I think there's just so many possibilities that get opened up when you look at something as innovative as this. So going from small scale to large scale, we have a specific question about utility scale, which I know you mentioned that you are beginning to target utility scale size projects. Is there any limit on that? This specifically is asking about a 50 megawatt plus size project.
No, there really isn't. You know, I don't want to downplay how big of a deal that is. You know, a large 50 megawatt plus project. We are actively bidding on 5, 10. I think the highest probably being 20 megawatt projects right now, and I can tell you that Phaser is getting a lot of attention, and mostly because from a utilities perspective, you kind of have locational needs. You know, you have this huge distribution system you're dealing with, and Phaser is so flexible that you can look at your, even as a retrofit, you can look at all the solar assets you have, and you can easily outfit part, some, or all of those solar assets with storage. You can have different sections of your, or different installations doing different things. Maybe one of them is on, you know, connected to a certain feeder, is concerned with frequency regulation, and so you would outfit it with a certain amount of phasers to attack that issue. And maybe on another one it's demand during certain hours, and so you would outfit it with a different amount of phasers. And you can even move the phasers because of how easily they are able to be installed. I think that flexibility and being able to address your entire distribution grid in kind of these pinpointed locational based strategies is really made possible by Phaser a lot more easily, at least, than with centralized storage systems.
Yeah. You know, I think we have time for maybe one more question, and then I think we'll hand it over to you for any closing thoughts. You mentioned frequency regulation as a possible, you know, grid service that you could provide. Are there any other specific services that you're looking at being able to provide with this, or looking at aggregating systems in different locations to do anything. I guess also related to this, for systems that are doing multiple functions, is it pretty well set where you say these units of phaser will be doing this and these will be doing something else? Or is that a variable that, depending on what the economics look like at different times, you can switch around how many units will be doing each thing that you'd like to target doing?
Yeah, another good question. So I think what you're asking really about is grid services, as we call them. Grid services, there's a lot of different ones emerging. Frequency regulation is certainly popular, demand response and demand shaving as well. I would say that we are 100% in the game of becoming a grid services provider and helping others do that as well. It's not just phaser that would be a good tool. I think it's this whole ecosystem again. We are bidding on projects for utilities where they need grid services, and we're offering this whole collection of products and being able to install different combinations at different places on the grid. When you're trying to perform these, like figuring out how to do multiple ones at once, that's another kind of new emerging topic, is dual use systems. And I'll tell you that after we've installed plenty of demand shavers in California, a lot of those ones are not being fully utilized all the time, or even microgrids. You install a battery system to be a backup, but how often does the power actually go out? And the reason I point that out is that means that there's plenty of uncapped or stranded assets out there. There's demand shavers that are only firing off 5 days a month, and there's plenty of energy left. And so what we're doing now is going back to those customers and setting up additional grid services contracts where we say, hey, we've installed your battery 2 years ago. We've looked at the performance through measures over time, and we've noticed that you typically have 40 to 50% of your available capacity for these certain months out of the year. Would you like to sign up for a grid services program like DRAM in California, for example, where we can use your batteries to help generate some extra money? We'll split that revenue with you, and we'll put a clause in here to protect the warranty period because we're using your batteries more. So hopefully that was helpful, but we're getting creative on how to use assets and dual use purposes for grid services.
No, that's great. And the fact that, in some situations that you actually go back and help people re-optimize their storage units for capacity that's not being utilized, that's a really great service as well. So I think we're going to end it there as far as questions go. Thank you so much, Roman, for all the helpful information, and Ellen for a great presentation. Do either of you have any last thoughts, things that we didn't get to cover? Anything else you'd like to tell folks before we end the webinar today?
I think we just want folks to know that they can reach out to us directly via email or via our website, and we'd be happy to follow up and continue any conversations that may have been sparked today by this presentation. And thanks again so much to you, Seth, and the team there for having us as part of your webinar series.
It was great to have you. So with that, I'm going to end my portion of the webinar. Sam, do you have any final thoughts for folks?
Yeah, well, I'd like to point out on your screen now, you should see some info where you can find more information about the Resilient Power Project. We have a website. We're also on Facebook and Twitter. And I'd also like to point out a few upcoming webinars that we have. A few are directly related to energy storage, but there's several others that might be of interest. You can find info on those webinars at cleanegroup.org/webinars. And we will be sending out a recording of this webinar within about 24 hours. Thank you, everybody, for joining us, and we hope to see you at the next one.